Hey TechKnowStuds! RFC 3021 outlines how we can use 31-bit prefixes. So in this video, let's take a look at 31-bit prefixes and how we can utilize them. With our WAN links, many times we only need two IP addresses. Here we have two links here, one right here and one right here, that really only have two interfaces on that links. So each one of these networks only needs two IP addresses. When we're subnetting addresses, we can use a /30. So in the case of a class C, we would borrow 6 bits. And then we would have a subnet mask of 255, 255, 255, 252. This would give us 64 networks. It would give us 4 hosts per network and 2 usable hosts because we have one for the network and one for the broadcast address. So by the time you remove the network and broadcast addresses, you only have 2 assignable addresses. So this is what we'd use for our WAN links. Now, it's pretty typical that we use these /30 for these WAN links, but it is a little wasteful because we only need 2 IP addresses and the network and broadcast addresses may not be as important. And so this is where the RFC 3021 comes into play. RFC 3021 allows us to start using 31-bit prefixes for IP version 4 addresses for things like point-to-point links. And so let's take a look at what this RFC 3021 looks like. What this standard allows us to do is use this /31 for 2 addresses. So now instead we can use both addresses that are found on this link, and it doubles how many networks we have from 64 to 128. So it's a lot less wasteful when it comes to our IP version 4 addresses. Let's do a little example here. Let's say we have a 10.10.10.10 network that we're working with. So converted into binary, this is what it looks like right here. And so then we now use the subnet mask right here. So here's the subnet mask, and we have just a 0 right here, which means that all the other bits here are network bits, but this last one is a host bit. And that host bit can be a 1 or a 0. So those are the 2 IP addresses within this network. So the 2 addresses that are assignable in this range would be a 10.10.10.10 that we would assign on one side, and then the 10.10.10.11 on the other side. Now, one of the questions that arises is what would be the network address for this? Well, it would still be the first address. 10.10.10.10/31 would be this network right here, but it doesn't really interfere with anything because this router right here could still have this network installed on the route, send the traffic this way to this router, and then this router knows it's a directly connected network and then can send it on to, if it's pinging 10.10.10.10, send it on to this interface right here. So it still works out. The network address can overlap with this interface address right here. So then the question is, what about broadcast, the broadcast address? Well, as far as the local network is concerned, for things like ARP, it uses the broadcast address of 255.255.255.255. And so this doesn't change at all in this network right here. We still have this broadcast being used between these 2 interfaces right here. But we also have the broadcast address for the network. So for instance, let's say I want to broadcast something from this laptop to this network right here. I would use the network broadcast for this network right here. However, if we're using a /31 and we have one address assigned to here and one address assigned to here, those are both being used and we no longer have a directed broadcast. This is not as common though. We don't really utilize these network or these directed broadcasts as much. The configuration for these routes are really quite simple. What we're going to do is we're going to just implement a route into one of these RFC 3021 networks. So what I'm going to do is I'm going to get into the global configuration mode, and then I'm going to use my IP route statement. I'm going to choose the destination network, which happens also to be the interface. So this is an interface IP address, but it also is the whole network, represents the whole network. And then I'm going to enter in the subnet mask. So this is the only difference here. We're just going to specify 254. And then what is the next hop? So in this case, maybe the next hop is a 10.240.2.1, and then we'd hit enter at this point. Simple as that. If we want to remove this, then we'd do the same statement, but we would add a no at the front of it, and then that would remove that statement.